So, hello. I'm here. I'm here somewhere right here. On July 21st, it's 12:14 early in the morning. Um, I feel like my weather videos are just boring, but I just have to do this one, so I'm going to do it. Now, this is the National Weather Service um, link. This whole huge thing here is a big blob of excessive heat warning. And the orange is heat advisory. And up here we have some storms. In my area where I live, it says excessive heat warning through Friday night. And it's still going to be hot into Saturday. But they're talking about heat index tomorrow, which is actually today, later on in the day, being up to 106, which is going to be a little uncomfortable. But I wanted you to see that because I think it's um, I think it's uh, like it's going to be a event, and people have been talking about it for a week. So the weather stations have known that this is going to happen, um, and I think it's being created. Let me show you a link. Now here on College of DuPage, which I will have the link below, they have all these links over here on the side, and this one, the Northern Hemisphere IR, I'll just wait for that to load. It has a couple of interesting things I want you to observe with me. You'll see these lines that come down here. Those are energy lines coming from somewhere, injecting some kind of energy into the atmosphere. Okay, I'm going to slow it down, and I'm going to make it so I can zoom in on it. Oh, that might be too slow. Let's stop it and just move it ahead one at a time. There's one. Okay, that's going right into this area or farther. Hold on, zoom it, zoom again. That's real noticeable. Then we'll go to a few more. These that we can see. Now this is only part of the atmosphere, so I can't see everything that's happening. Here's the timestamp on that. And this is going right into this storm area. And there's another one, and this one down here that I'm not sure where it's going to. And then I thought there was another one here. And we can see these clouds like building, and right in here where the heat is blank. Now what I've been seeing during the day is it's been really cloudy. It looked like it was going to rain more than once. And then, oh, this is starting from the beginning again now. And then the clouds would just disappear. Let me see if I can show you an example of that. Okay, this is the infrared satellite for Illinois. Now if you watch, I'm going to slow it down just a little. You can see the clouds, and it was dark, it looked like it was going to rain. And then they just disappear. They just dissolve in the air. And it's not hot enough yet to just have that just dissolve. And it was really weird to see, because even when it was cloudy, there were clouds below this that would just disappear. Now this is the visible satellite, and this is a 24-hour satellite. See, it gets all cloudy, doesn't rain, and then the clouds just go away. One more time. Now this is the radar loop, and as you can see, there are some like clouds, or it looks like storm patterns that will, like here, that just disappear. And radar does add energy into the atmosphere. So it looks like they're creating miserable times. And right up here where the storm is, the radar looks different, see here, than it does down here where it's supposed to get really hot. See, look at that. And it's allowing that storm to come right through there, is what it looks like to me. Now watch what happens down here. See that? And then it just disappears. This thing in Texas has been like a crazy thing for a couple of years, the way these go up here. And the color of them even is different than in other places. So that's what I think about that. I think this is all human created, or, you know, it's created. It's not just a natural thing that's happening. Okay, now this is the radar in my area, and as you can see, these clouds are coming in. The radar gets huge. It goes all the way around this whole huge area to southern Wisconsin, and the clouds just evaporate. Oops, that's right in this area right here. See how that happens? Okay. Just disappear. And here's the timestamp on that. This thing up here, all I have to do is move my mouse over to this side. It goes up. See if we can get it to go up and show us the water vapor. For the heck of it. This is really kind of a fun, website, College of Page, if you like the weather. Now, this is the base reflectivity in Goodland, Kansas. Excuse me. Oops. Oh, come on. These lines right here, excuse me, I believe are wind, but see this pattern here? There's one there, this right here. Come on, go away. And then we've got this beam coming down here. Oh. In order to move it, I have to keep moving the mouse over there, so. So we'll just watch that move. And then it has that one weird black and white picture that shows up that I think is interesting. That one. And you can see the strange pattern right here. It's a strange thing. But you can also see the lines in here that look like it could be wind, or it looks like chemtrails moving along. And here also. And I want you to watch this storm relative radar, what this looks like here in Goodland. Okay. See this beam coming out here, and then look at that stuff. That looks really bizarre, what's happening here. See that? And there's something that the radar that is beaming out toward it even. But the central area is where it seems to be bending from. See that? Okay. I want to show you this radar also from Lubbock, Texas, because it's so huge. Look at how far it goes out. This is 100 miles that it's expanding out to. It's ridiculous. I like looking at the storm relative mean velocity. Oh, what a time to get a dry spot in my throat. That's a huge amount of energy. Supposedly for our protection against storms, right? Here's the timestamp. Okay, now I just want to show you this water vapor for South Central USA. Okay, now as you can see, this is the part that I was showing you, the radar that goes out 100 miles, which doesn't really support the use of that by the clouds that are right there. You can see that, correct? And this is where we were looking at in Wisconsin that doesn't really support, but this is where the heat is supposed to be tomorrow and into Friday, where the radar is very intense. Okay, that's one thing I want you to see and notice. The way the clouds are moving and bending around that. Okay, this is the World Health Organization on electromagnetic fields and public health, radars and human health. Radars detect the presence, detection, or range of aircraft, ships, or other unusually moving objects. This is achieved by sending pulses of high-frequency electromagnetic fields, EMF. Invented some 60 years ago, radar systems have been widely used for navigation, aviation, national defense, and weather forecasting. Their primary objective is individual and collective safety and protection. People who live or routinely work around radars have expressed concerns about long-term adverse effects of these systems on health, including cancer, reproductive malfunction, cataracts, and changes in behavior or development of children. A recent example has been the alleged increase in testicular cancer in police using speed control handheld radar guns. It is important to distinguish between perceived and real dangers that radars pose, as well as to understand the rationale behind existing international standards and protective measures used today. I think it's important to educate yourself and make your own decisions about what it is you want. So here they talk about how these fields penetrate exposed tissues and produce heating due to energy absorption. Now, you know that also does that to the atmosphere, as well as every body, plants, human, any kind of animal. And then here we go into human exposure and what it does. And they're basically saying here that it's not a danger. Right here it says they pose no hazards to the general public. But let's go up here and look at this line. Under normal conditions. Okay. And up here it says they operate at higher frequencies but generally have lower average and peak powers, whatever that means. Okay, so most studies conducted to date examine the health effects other than cancer. And then it goes on and tells you a little bit about it here. We go down into cancer-related studies. Thermal effects have been studied in animals, including primates. The earliest signs of an adverse health consequence found in animals as the level of RF fields increased include reduced endurance, aversion of the field, and decreased ability to perform mental tasks. That's enough right there to cause concern. So let's take a look at the map one more time. Here is the radar map of the United States, the lower continent part of the United States. Now, that to me looks pretty intense. And I just want to show you a trick they do. This is in telecast, and I like this map for other reasons besides what I'm going to show you here. But this looks like what the radar is. It doesn't look anything like what we saw here on College of DuPage. This looks like no big deal, and it looks like it's just telling you where the storms are, correct? Here, once again, comparison. So this looks pretty dang safe, doesn't it? Compared to, wow. Okay, real quick, look at Antarctica on here and look at the northern hemisphere. Antarctica has a bunch of stuff going on all the time. Okay, here on weather.org, the radar looks just crazy in the United States. I'm grateful for you, and I'm here at your service.